In this video, we're going to talk about the functions in ELMER that are used to summarize several results. The first step we need for this part of this script is to download this folder, Analysis April 2019, which contains several ELMER runs. We have ESCA and unsupervised, for example, and then we have two runs, adeno versus squamous and adeno versus normal. And also BAAD, also tumor versus normal. And the fourth one was the Coetzee and red unsupervised tumor versus normal. So we have these 4 runs. So the first step we need is to point to get the folder with the results. And this is the code I used. So dir is a function in R that you point to the directory, and then it's going to show you all the files recursively. I said recursively, and all the full names. And then I said I want the directory names and I want unique names. So this is going to give me mainly the folders for analysis. And then you have to define which granularity you want, if it's like subfamily or family for the transcription factor classification. We are using the most stringent one, subfamily. And then we have this function, which is called get tabs, and you set like directories in the classification. It's mainly going to through all folders, and it's going to read the results from each CSV file. And after this, you should have like 4 tables, okay? So just to show tabs, they are each one, I think they're a list. So the first one is a binary matrix saying if for that analysis, if the transcription factor were identified or not as a top one within the subfamily. One thing that you can notice is the names are actually the paths, so we are going to change that later. So we have tab that gives us the binary matrix, tab p-value, which actually gives the p-value of that transcription factor between the average dynamic methylation and the TF expression. We have also the odds ratio between that TF and in the analysis. Basically, the enriched motif in which that TF was identified, we simply get the highest odds ratio, and we put in this table. And the last one is the transcription factor odds ratio table. So it's going to give you the transcription factor, which is the motif it's binding, in the FDR between them. So it's another way we summarize the table. It's going to be used later for plotting purpose. So the first thing we do is actually renaming. Instead of having the path files as columns, we're going to use rename them. Okay, so we use these functions. We use only the first 3 data tables because the last one, as we can see here, it's not on the same format as the first ones. So then I get the tables. Instead of being a list, I rename the last table. So now we have the TF, the motif, the FDR, and in which analysis was identified instead of the path. And then we're going to plot. So the first thing we are going to do, we're going to plot the binary table. Okay, so the heat map here, I'm going to execute here. Let's see. Okay. Then if you run this, I'm going to try to explain the code line by line. Let's see. You should have the heat map draw. Did I have both? Yeah, so I had, let me clean and redo the code. Yeah, so this is going to plot two heat maps. One it's binary, saying in which analysis the TF was found, and the other one has the like a p-value. So this function is actually going to, you get the table with the p-values, and then you say, okay, I wanted the top 10 or top 30, or I want all the labels, and then it's going to give you the ones that have like the lowest p-values, the most significant ones. Then we create the annotation, which is this part on the top, saying which is the analysis. So we just did unsupervised analysis, and in which analysis it was identified. So we have the 4 names. Then we set the colors, and then we plot the heat map. So the first one, we plot the tab binary. We set like 1 to be black, 0 to be white. We cluster them by a Jacquard distance with average clustering method, and basically that's the first part. And then we add the names with this function. It's called row annotation, and say, okay, I want to show these labels here, basically. And then the draw is going to draw the heat map. And the other ones, simply we change instead of binary, we set the p-value, but we take the minus log 10 FTR. And one thing that we do, we use the same clustering than the previous one using the tab binary. And that's the first part. The other plot we want to check not only which are the TFs, but also the anti-correlation between the TF expression and the average denamethylation binding sites. So that's what the next codes are going to do. Since the data I provided is only ASCII, that's the one we will only work, so I'm going to get only the ASCII results. We load the data, which should have 100, I believe it's 171 samples. Let me reload the data. Instead of running the functions again, I actually selected just the second and the third results from the p-value, which are only the ASCII results. Then we call some libraries, and we select how many TFs we want to plot. We select 5, so we could like have more than it. So we're going to get the top 5 in each analysis. So for each analysis, what we do is basically, let me find the font. We do the scatter plot by TF and the probes in the enriched motif. So we select the top TFs, and then we also select, we read here the enriched motifs results. So with that, we have the probes, we have the TF, and then we're going simply to pass to the scatter plot the data, say, okay, these are my probes, this is my TF, and then it's going to plot. The rest of the code, it's simply to create this grid. So we plot this, then this, then this, then this, then this. Then we go to the second analysis. That's mainly what we're doing. So let me run this. So the scatter grid, it's going to be a list. Let me check. And I believe each so each object is going to be one line of that grid plot. And then we use this function, say, okay, here are my list of plots. I want one column and how many rows we want. So we have two analyses, we want two. And basically, that's what we're going to plot here. You can control the size of the plot later, clicking on export, or even saving to an object and use like a function like ggsave. And more or less this is what you should get, and the top TFs for each analysis, which should be consistent with the heat map. Here we see that, which one were the top one? For the EAC versus SC, which is the red one, which is this one, we can see that HN for A is one of the highest ones, and NH for 1A is also. This is probably the top 5 we have plotted there. Yeah, so this is the top 5 we plotted there. So that's it for those functions, and they're not that straightforward like the ones from ELMER, but they are extremely useful for summarizing the results.